field data collection using smartphones, tablets, and GPS devices.
I'll talk at the business meeting about who this group should be pursuing in terms of members in the future. Made me think, last May marked the 30-year anniversary since I got my degree in GIS. My advisor was David Mark, who is still at SUNY Buffalo, and Dwayne Marble was my first professor. And we've been doing this for a long time. One of the things that both Mary Pirelli could not be here today. She's our GIS lab technician. But one of the things we worry about most in our education program is teaching kids to be button pushers instead of understanding what it is they're actually doing and why. And the danger of that has become even worse with all these tutorials that are out, where, you know, it's do this and then click this and then click this. And they run through these tutorials and they have no idea what they just did or why they did it. And when you give them a similar problem without the click this, then click that, you run into the problem where they didn't learn a thing. So what we try to do is we try to give our students as much hands-on activity as we can so that they can learn by experience, and hopefully they'll have a lot of failures so that they will learn even more. So this is just a brief outline. This is going to be really quick. One of the things that I don't know, if you're car shoppers, you go out and you get the EPA mileage of the city and highway mileage, and then you talk to the salesperson and they say, oh yeah, but you could probably get, you know, this much or that much. One of the things that we worry about with all these technologies is a similar sort of issue in terms of spatial accuracy, that there's this range of spatial accuracy, and we all know that the accuracy, the spatial accuracy, is more important for certain types of features than others, because certain types of features are very hard to describe as either a point line or polygon. But we still have to think about the topic of spatial accuracy, and so what we wanted to do was to test essentially 3 different methods of data collection. We wanted the students to test 3 different methods of data collection and see if there was one or more that was more consistently accurate. I have a question mark after the term cost. I can tell you the cost issues we face. Last spring, one of our students broke a $6,000 GPS unit, and it took the entire summer to get it fixed, which cost us a lot more. So for us, any student, and they all have smartphones, can go to the library and sign out any kind of laptop they want, okay? All you have to do is make a reservation, and you go to the library and you pick up your laptop, and you can sign it out for as many days as you want. So we were really thinking that in terms of cost, it would be a lot cheaper if we could move away from the GPS units that, you know, colleges don't really have a lot of money to spend on a lot of equipment, especially this year when they cut all our salaries. So it's important that we care about cost. The people who do this for a living obviously are going to have other cost parameters, so we didn't really want to address the cost. We were concerned with the type of features, and I'm going to show you 3 different case studies. One of the important things with the students was whether or not the feature that they were capturing was actually visible from the satellite imagery or the aerial photography that was being used as the base map. However, we did test accuracy when the features were not visible, so we actually looked at both aspects of that. As I said, all of our students have smartphones. You know, I don't, but they do, and all of them, you know, have used tablets, and so in terms of accessibility and familiarity with the technology, it's sort of a no-brainer to really try to implement that technology as best you can. We also dealt with the online versus offline issue. For the data collection that they do on campus, they are online everywhere. So they can log into our campus network, and they have access anywhere they go in the campus through Wi-Fi. For offline, the college was nice enough to purchase me and pay for MiFi device, the Verizon MiFi device. So we actually went through a few things. We did use ArcGIS Online. This all occurred before the collector app was made available. Okay, we've been doing this for a while. Why do we use ArcGIS Online? Because we teach in ArcGIS ArcInfo. Okay, so it was a no-brainer for students who are learning ArcGIS ArcInfo to use an ArcGIS app. The other thing is ESRI is great in their business model because they give us subscriptions. So we don't have to worry about what everybody else worries about in terms of running out of credits and that sort of thing. Because we're using it for educational purposes and we're an educational institution, they very nicely give us access to it. I did contact Trimble. They have, I think it's TerraFlex, their software, and asked them if they had the same sort of policy, and I'm still waiting to hear back from them. That was about 5 months ago. So we're going to stick with ESRI right now because they like educational institutions. These are just pictures of the two different types of devices we use. The Trimble is supposed to have 3 meter or less accuracy. The other one is just a little Garmin E-Trex. And what we did, given the students' history with GPS, is we let them take the Garmins out for their GPS data collection, and we used the Trimble. This is just the MiFi device that they let us use. The apps, they could collect data using iPods, Androids. I have my iPod. My iPod is about this big. And I did the first data collection scenario using my iPod, which is tiny. Some of them use their smartphones. A lot of them chose the iPad as opposed to the Android, but you know, there wasn't really a huge difference there. One of the things that I love about moving into the ArcGIS online applications is you can still create your geodatabases, and the key point is you can create domains. And in my 30 years of this stuff, my experience is the least quality information you get has to deal with the attributes. That people do not enter attributes very well. And if you've ever used ArcPad, you know that you get a similar sort of domain capability. But by allowing us to set domains, we can control, at least for the most part, the number of bad answers. We can't control that they picked the wrong thing, but we can control the fact that they only have a few choices as to what to pick. So that's really important. The other thing that is really helpful with all of this technology, the iPad technology, is the fact you're limited to how far you can zoom in, okay? But when you touch the screen and drag along the screen, you do get the ability to zoom in even more. And that really does help with positioning. So that's another nice feature of the technology. We did use subtypes for the students' data collection, so that the first top one up there is the subtype. The first exercise, all we really wanted them to tell us was whether or not they were using the device GPS to locate the point, or whether they manually located the point with their finger. And then we asked them to provide information on which location they were actually at. We gave them 10 different sites on campus that they were supposed to collect data. The other picture there is just to show that I really love the text entry capabilities on these iPads. It just, you know, again, I come from the days where we didn't even have desktop computers. So this stuff is all really cool for me. We did use the World Imagery Base Map, and I just highlighted what ESRI says, 0.3 meter resolution imagery in continental U.S. when we work offline on our desktop, we always use the New York State digital orthoimagery, which is, has a different datum from the world imagery, and so we have to address the datum transformation issues that students normally totally ignore, because when you talk about maps and projections and those sorts of things, they don't, why do I care about that, right? But in this example, they had to think about that they had two different datums that they were dealing with. One of the biggest issues is currency. This is today's digital orthophoto from New York State. See that big gray block? That's that building I took a picture of on my way here in my office, from my office actually. We have a problem with currency, and that, when I was, the UPS man yesterday was talking about how the maps we have today are not nearly as good as the maps they have. I would have to second that in that, basically the data that we have today to work from isn't as accurate as it could be in terms of up-to-date and current. But that's an ongoing problem with GIS, is that, you collect data and then something's changed and you have to collect the data again and again and again, and so we face that all the time. The first exercise, we had two classes, this is a required course for both the geography and the planning majors, maps and mapmaking using GIS. Mary Curley teaches the course. I teach the fundamentals of GIS and the advanced GIS and the urban apps of GIS, so she takes this one and I take the others. This is also a required course for the GIS minor, so anyone in the college who chooses to do a minor in GIS also has to take this course. They're mostly sophomore level students. These are the locations, and what we wanted them to do, because they're supposed to be learning about map making, we wanted them to be able to find locations based on some description. All right? We didn't give them pictures of where they were supposed to go. We didn't give them a map of where they were supposed to go. We gave them a list of the places that they were supposed to go. And so it was up to them to figure out where they should actually be collecting the data. Now, they did not do all three data collection methods at the time. They were sent out 3 separate times, all right? So it wasn't like they were standing there trying to do all 3 things at the same time. We broke it up in 2-week intervals so that, it would be a little bit more fair. Basically, I've already told you what you use. This is a map of what we're calling the known feature locations. Now, the red stars, I know they're sort of hard to see. I tried to put numbers next to some of them. The red stars are the ones that we captured using my tiny little iPod. Mary and I went out to set up the exercise, and we used my tiny little iPod. The yellow dots next to the red stars are using the Trimble GPS. We went out on another day and used the Trimble GPS. So we actually had 2 sets of known locations, those that we captured manually and those that we captured using the Trimble GPS. And you can see that the mean distance between those 2 sets is 2.6 meters. In theory, within the 3-meter tolerance of the Trimble GPS. So we, because we were getting slightly different results from those 2 approaches, all of the analysis is done with respect to those 2 approaches. But the other thing I want to show you, if you've ever used a Trimble, you have when you go out with a GPS device in Trimble, there's a little satellite button. And if you click on that, touch that satellite button with your stylus, it'll take the point wherever it is on your map. You can also, if you think you're really good, touch the point with your stylus and forget about the satellite stuff. Say, oh, I see where that is, and click on it. We went out another day with just using the stylus, and see all those yellow dots there? Those are the GPS locations using the stylus. Okay, so the orange dots are the GPS locations using the satellite buttons. The yellow dots are the GPS location using the stylus, and the red stars are the GPS or the manual locations using the iPod. And this is just 3 of our locations. It gets worse when you, I could take you to some other places that were slightly worse. The analysis that we did, basically, the students were told they were being graded on these exercises. That didn't seem to be very much incentive because it took me about 2 weeks to clean up their data. You know, it's just amazing to me how, I don't know what you got to do to get people to do a very conscientious data collection, but it was somewhat disappointing. So the sample size, this first set is if you use the nearest point tool in the ARC toolbox. So it uses the entire sample size, and these are the mean measurements to the nearest point. So in the top case, the manual method, the students who use the manual method, that comparing it to our manual points, the mean distance was 8.1 meters, and to the GPS was 9.2 meters. The device GPS, I would never recommend anyone ever using the device GPS. And we were not using a single device. We were using iPods, iPads, Android tablets, all sorts of. The device GPS, the average distance, mean distance is 30.1 meters to the manual and 30.5 to the GPS. And then the Garmin, the handheld, they went out with their little handheld Garmins and they were supposed to stand there and get the coordinates, 14 meters. All right, so the manual, obviously they perform better with the manual. The second table is when you map to the nearest point isn't necessarily the point that it was supposed to be. So they might have had a point that was closest to the stop sign, but it was supposed to be the pine tree, okay? So when I eliminated those discrepancies and just used a slightly smaller sample size, the manual still comes out far and away the best in terms of the approach for the best spatial accuracy. Okay, this is just the z-test, and I'll just go back for 1 second. The z-test, when you're comparing the manual, our manual, the mean to the manual to the mean to the GPS, you fail to reject the null hypothesis that the two means are equal. So in a sense, those two means are equal this way from the known points over. When you compare among the methods, you reject the null hypothesis that the means are equal. And the p-values are up here, so you can see that that's fairly strong. This is the standard distance, and I just wanted to show you, this is using their standard distance tool. You can hardly even see the orange or the manual, and on most of these, down in here you can't even see the standard distance circle for the manual method. The yellow are the handheld GPS, and the greenish blue are the device GPS. And just from that you can see that the device GPS is not something that we would ever recommend using for data collection. So what did we do next? The City of Buffalo gave us their streetlight database. They currently pay $10 million a year to National Grid for streetlights, and they're not quite sure what they had out there. So they hired a consultant a few years back to actually create a spatial database of their streetlights. We do not know how the consultant did this. All right, all they did was give me the point database with the records. And I said, okay, fine, we'll go out and we'll do Elmwood Avenue, which runs north and south by our campus. And so this is the database that they gave us. The Elmwood Ave streetlights are highlighted. That big blank area up there, that's Forest Lawn Cemetery. And you can see the Olmsted Parkways, the circle and the parkways going down through there. So this is the data that they gave us. This is the data the consultant gave us. We actually collected a lot more information. The consultant didn't collect any attributes at all about the streetlights, and they wanted to know which streetlights had police cameras, which ones had gunshot detectors, because that equipment needs to be replaced if somebody runs over the streetlight or knocks it down with their truck. So we collected a lot of different information about these, including the pole identification number. These are the streetlights that we collected, and again, this is mapped to the New York digital orthoimagery. what we ran into is we had streetlights that we collected that were not part of the City of Buffalo's database, and then we had points in their database that actually, they had 2 points at the same locations. Basically, when you get rid of the points that didn't have a corresponding point in our database, so the ones that they had plotted that weren't there, the average distance between a manual data collection and their points was 2.8 meters, 82% are within 3.5 meters. So then we went on to invisible storm drains. We're working on a grant with the county, Erie and Niagara counties. They're doing a storm drain collection. Now, when they go out and do this, they have to actually lift up the storm drains and look at where the flow is and all that sort of thing. I just went out, this is in Wheatfield, it's a very suburban community, it's just south of the Niagara Falls Air Force Base, and these are their GPS points, and I went out with just a laptop, I never got out of the car, and I manually identified the locations of storm drains. Basically, I was within 6.24 meters of where their GPS storm drain locations were. And I just want to show this very last one. What are the points? There they are. Why is it doing that? Okay, the pink points are theirs and the yellow points are mine, and you can see that some of their pink points are obviously not where there are storm drains. So, you know, whose was more correct? But, you know, this was just another fun exercise to look at, you know, the manual data collection method. Basically, I would say it's the best approach right now that we have, especially if you can't afford fancy GPS devices. But one thing to caution you on is if you have a tablet, no matter which direction you turn, north is always up. And if you have people who are not good map readers and haven't been doing it for 30 years, they don't know how to reorient themselves. So if you're walking south on Elmwood, but the map is north looking up, you have to be able to switch in your mind, the actual location. So that's the one downside, is you really have to have some level of skill. Again, I would never use a device GPS for data collection, and the handheld was also obviously subject to human error. And this is just our contact information. Any questions? Okay.
Would you consider using a supplemental GPS with the device GPSs, like a Bluetooth GPS, to maybe improve some of the accuracy?
Well, we tested that. We had some of the students with the smartphones with the 4G, the Bluetooth GPS stuff through that, and we didn't see really much more in terms of the accuracy. So, you know, and again, I think it has to do with your circumstances.
What was the method that the City of Buffalo used in order to inventory their streetlight data set?
I have no idea. A consultant did it a few years ago. I think it was URS. I was under the impression that they just tried to geocode them based on street address, because the streetlights have a number which is supposed to correspond to the parcel or building number. And from what I could see, that's what it looked like. But, you know, I really don't know.
I'm sorry, we really need to move on to our next two presenters. We don't have